Kubernetes is the container management platform that came out of Google's experiences managing data centers. Kubernetes abstracts away many of the frustrations of distributed systems management. OpenShift is a platform built on top of Kubernetes to provide an additional layer of usability. Clayton Coleman is the lead engineer of OpenShift, which originated at Red Hat. And in our conversation today, we start with the basics of Kubernetes, and then we talk about OpenShift. And Clayton explains why we need another abstraction on top of Kubernetes. Near the end of our conversation today, we discuss the current state of cloud products, which can be so confusing. Mesosphere, Swarm, Kubernetes, OpenStack, ECS, OpenShift. Why do we need all of these different products? Clayton gives his perspective and explains why it is not going to get any less confusing anytime soon. If you enjoyed the episode today, please share it on Facebook or Twitter, or tell your friends somehow. Word of mouth is how this show grows, and I think there are a lot of episodes where people are big fans of them, but fewer people know about them than there are people that would be potentially interested in them. So please do share. And if you have any comments or criticism or suggestions or anything, or you just want to say hi, send me an email at softwareengineeringdaily@gmail.com. I'm always looking for new show ideas, recommendations, criticism, suggestions. Thanks for listening to the show. I appreciate it. And now let's get on with this episode after a quick word from our sponsor. Software engineers never stop learning. If you are listening to Software Engineering Daily right now, you enjoy learning so much that you listen to a podcast about technical software topics. IT Pro TV has videos for people like us, people who never stop learning. I'm using IT Pro TV right now to learn about Amazon Web Services, and I found 10 hours of high-quality videos about EC2, elastic load balancers, orchestration, cost management. If I ever decide to start my own tech company, I will need to know how to manage the cost of my servers. Go to itpro.tv/sedaily to get started with a free 7-day trial of videos. You can then use the promo code SEDaily and get a 30% discount, and that discount is permanent. Watching these videos, I have learned how to configure auto-scaling groups together with load balancers. I've learned how to configure a database that can scale up without inconsistencies. If I wanted to test out of the Amazon SysOps certification right now, I could. There are also courses about Microsoft operating systems and networking, VMware virtualization, Cisco routing. You can watch 70 hours about Cisco routing and switching, and it is engaging and entertaining material. If you listen to Software Engineering Daily all the time, this is the kind of material that you will love. You can put it on in the background, and you will find yourself just absorbing the information without even realizing it. You can try it free for 7 days. Go to itpro.tv/sedaily. Use the promo code SEDaily to get 30% off, and after you try it free for 7 days, I have no doubt that you will want to continue to invest in yourself and your future. Thanks to IT Pro TV for sponsoring Software Engineering Daily and for producing this top quality content. Clayton Coleman is the lead engineer of OpenShift. Clayton, welcome to Software Engineering Daily.
Great, it's great to be here.
We've done a number of shows about Kubernetes, which is the container orchestration and management tool from Google. So I want to start by talking about Kubernetes because it's closely related to OpenShift. Give us a brief history on how Kubernetes evolved and what Kubernetes is today.
Sure. So I got involved in Kubernetes actually before it was released to the public. We'd been talking with Google about wanting to see the kind of the evolution of containers and some of the ideas that Google likes to talk about in their papers, bringing that to kind of the wider audience. And they had been considering for a long time open sourcing something like Kubernetes. And so we saw, we got to see an early demo and had some great chats with them. When Kubernetes was released, we I was involved from kind of the very beginning. We've been discussing with them, and when they open sourced it, they asked Red Hat to be a partner in the Kubernetes project. Red Hat has a long history of helping nurture and grow open source communities, and this being a topic that was very near and dear to our hearts from the Red Hat side, we were really excited to get involved, and so I think I was the first external committer to Kubernetes. And, from the very beginning, it was a real small team, but you could really tell that there was something really exciting about the ideas, taking patterns that you've seen, I've been working on, platform as a service and, web application software pretty much my entire career. But a lot of the ideas that are part of Kubernetes, those core patterns, you see them and you say, you know what, this really is a better abstraction. They've been refined by Google internally and the systems and, practices they use, but there was also something to them that was the kind of the elegant simplicity of some of those ideas. And as, we spent a ton of time in that first year, just trying to hack to the point where we could get a production Kubernetes 1.0 release, and a bunch of other people got involved. It was a lot of excitement in working on Kubernetes. It's been one of the certainly a singular experience in my life, being able to to participate in a community with as many people who are as excited about making something that really does help make running software at scale easier.
The excitement really is palpable, and I certainly see it in the numbers when I do episodes on Kubernetes, and I have these guests on who are Kubernetes experts. The shows perform extremely well, and it's quite obvious that there is something here that is changing how we build software. So let's talk about some of the main abstractions within Kubernetes, which are a pod, a service, and a replication controller. And listeners who have been tuning in probably have heard these explanations before on previous episodes, but I think it's important, especially for people who are not working with these things on a day-to-day basis, to have these things redefined, because they're going to be primitives that we are going to be working with for a long time. So what is a pod? What is a service? What is a replication controller? And am I missing out on any of the core abstractions of Kubernetes?
So I'll start kind of at that base level. So the pod, a lot of people are used to talking about containers. And if you've come from, if you haven't been asleep for the last 10 years, we've been talking about VMs for a long time. And I think the pod is the necessary bit of abstraction, syntactic sugar around a single container that makes it feel just enough like a VM that you can bring a lot more workloads and types of applications to run in containers. And I think a lot of people who've been working with Docker for a long time have seen this, is that the vast majority of the time, maybe 75, 80% of the time, single container, your web application talking to your database works great. But every now and then you hit this pattern where you say, you know what, I really need two processes. I might need a web application and a web server. So a lot of people do Nginx or HA proxy or Apache sitting in front of something like Ruby and running the Unicorn web server, for example. And every time they do that, there's kind of this little moment where they're like, well, what I really want is Apache and Ruby, but I don't want my Apache stuff to be too closely coupled to my Ruby. And I don't want my Ruby to have to, every time I update Ruby, I don't necessarily want to update my Apache stuff. And I think that pod is that thing that binds it together, which is it's just enough glue that you can take all the patterns that you have when you think about single machines or VMs and apply it to containers. And it gives you a nice place to hook on some of the other stuff that doesn't really change a lot. Like, for instance, if you are talking two things together, a lot of times, if you're doing local development, you talk to stuff over localhost. MySQL starts up and it starts listening on the MySQL socket, or it starts listening on localhost at port 3306, and your web application is used to talking to it on that port. There's kind of this nice idea as well, which is, well, those two containers, sometimes they share file system, and if they share file system, they need to be on the same machine. And if they're on the same machine, you either got to go create this really complex concept to link them together, or and treat them as two independent containers, or you say, well, they're really just part of the same unit. And that's really what a pod is as well. And so each of these kind of things is just a little bit of syntactic sugar, a little bit of an abstraction that lets you kind of step back and be like, oh, it's just like a mini VM. On top of that, replication controllers are really the first kind of primitive in Kubernetes that's the higher level. So it says, I want multiple copies of a single pod, and if any of them go away, I deal with all the messy details of going and creating a new one. And I deal with the messy details of waiting for pods to go away. So a replication controller really is just a template for a pod that stamps out those new copies. But it also kind of enshrines one of those core Kubernetes concepts, which is the idea of a controller. And the controller just says, well, hey, you told me what to go do. And my job is to make sure that's true. So the replication controller says, I want 5 copies of this pod, and there's some little process in the background that's handling that in Kubernetes. That means that you don't have to think about it anymore. And all the rest of the software that needs to deal with it doesn't have to think about it as well. You don't have to worry that there's 6 or 4 or 10, because if you wait long enough, there's going to be 5 again. And that's a really powerful pattern that is kind of the bedrock of a lot of the design choices in Kubernetes is the world's a complicated, messy place, and what you really want to get, what you strive for, and not everybody always achieves this, is what you strive for is to declare what you want and then have a whole bunch of really complicated software go do the right thing. And the replication controller is really the simplest example of that in Kubernetes. And then, obviously, if you have a whole bunch of these pods and containers running, the next thing is that somebody else needs to be able to actually connect to those. And so a service in Kubernetes is really the idea of a simple load balancer, a self-contained unit. And you don't have to really worry about the details in Kubernetes. The details are there if you want them. But when you create a service, you say, go find all of the pods that have these labels. And a label is just a key value pair that pods can have. And it allows you to say, go find all of the pods and surface them through a load balancer, or surface them through a DNS name, or don't surface them through a load balancer, but expose an Amazon or GCE load balancer to handle all the details. So it's really, again, it's a declarative. I want anything, any pod, any container I have that says it's part of my web tier to be surfaced via this single endpoint. And then the flip side of services is somebody else has to be able to access that. So that's tied into DNS in Kubernetes so that every service you create has a DNS name, and you can predictably go and access it from other pods. So those are really the 3 fundamental abstractions, and everything else in Kubernetes really builds around. There's tons of other concepts. So many. We're probably going to at some point stop adding concepts, but there's a lot of other pieces that are really fundamental parts of distributed systems to support those that build on those same ideas.
Well, the advantage of Kubernetes is that it does abstract away so many of those distributed systems problems that have been causing us headaches for years and that have been aggregated by the rise of cloud. And if you're in AWS, nodes are failing all the time, and this creates this anxiety where you don't want to have to worry about these machines that are transient and they're going to fail. One thing that Kubernetes gets us is this: you can treat things at the level of a service. You don't have to treat it at the level of the machine. So you get this cattle not pets ideal, where you don't have to think of like, oh, this is box, VM 1 2 3 4 5 6 7. I need to make sure VM 1 2 3 4 5 6 7 stays alive. You can just think in terms of the abstraction of a service, and you can know with confidence that the service will take care of all of the underlying plumbing of if a box fails. It's going to fail. The service is going to fail over to some other box, and so you get this glorious abstraction away from distributed systems, and that is the platform that creates all of this opportunity. And I think that's what you're getting at when you say, like, there's such a fundamental change that we can just build and build and build and build on top of this because it takes away such a big headache. So when did Red Hat get involved with Kubernetes?
So I think it was the second day that the Kubernetes public repo was out there. So after Google announced Kubernetes at Google I/O.
Did you say that Google came to Red Hat or Red Hat came to Google?
We had been discussing, at Red Hat, I work on the OpenShift team, and OpenShift is platform as a service. We've been looking around. We saw the rise of Docker, and we saw we knew that there was a new opportunity to build a better platform as a service. Kind of the first generation and second generation platform as a service was, 12-factor apps, very simple, stateless. You can adopt the mindset and you get benefits, but not everything fits into that neat box. And we were looking for an opportunity to build something. So we had been discussing with Google kind of the idea of seeing what's out there. We had considered Mesos, and we've been working with Docker for a long time, and some of the other people in the community. We worked with the OpenStack project a little bit, and we were really looking for the right fundamental abstraction for the distributed system for for cloud native applications. And so we, when Google open sourced Kubernetes, I think the second day, I opened a PR, and I still see the comments on that PR thread occasionally. It's kind of it was one of the first things I changed, and I occasionally still get bugs in that. But, kind of from day one, Red Hat and the people on the OpenShift team and in the larger Red Hat, open source community have been really heavily involved in Kubernetes and trying to make it successful, both as a community and as a tool for people to deploy and build applications.
So let's get into OpenShift. What is OpenShift?
So the old answer I would have given would be OpenShift as platform as a service. And just like Heroku or Cloud Foundry, it focused on making it easy for developers to push buttons and get simple web applications spun up that could consume databases. I think a little bit unlike Heroku or Cloud Foundry, OpenShift had kind of started with the mindset that we wanted to make it possible to run stateful applications. But at the time, when OpenShift started in 2011, the underlying concepts in the Linux kernel for running containers were somewhat new. And so, we started working with, kind of those fundamental primitives, and we supported building things with RPMs. And as we built up, we realized, well, we are a platform as a service, but we want to be something different. So now when people ask me what OpenShift is, I would say OpenShift is a platform for building cloud native applications, and that includes stateless 12-factor apps, but it also includes that whole other class of applications, which is really being a place to run every kind of software. And we're not there yet, but I'd like to think that that's the big picture, is to be able to run all the world's software.
We have Kubernetes. We already talked about all the value of Kubernetes. Why do we need a higher level abstraction like OpenShift?
So OpenShift is, at the time that Kubernetes started, Kubernetes was primarily a runtime system. So, we talked about those concepts of pods and replication controllers and services. And those abstractions, the next question is, okay, well, I want to build applications. Well, what do I need? Well, I need to change those applications. I need to roll out deployments. I want to expose those applications not just to other services within inside the cluster, but I want to expose them outside of my cluster. I want to do load balancing at a HTTP level. And so at the same time that we're contributing to Kubernetes to help build up those core runtime concepts, in OpenShift we built the things that you need to manage and roll out images. So just like we talk about containers, the big benefit of containers is the ability to deploy images that contain everything in them, the ability to treat them immutably and to roll them out. But you actually need a system for building and managing those. So on top of Kubernetes, OpenShift originally offered deployments, images, the ability to manage, an integrated Docker registry that could do access control and quota and promotion of images across the whole cluster, as well as builds, and not just Docker builds, but also simpler builds where a developer just brings source code, and that source code gets built into a runtime environment, a little bit like Heroku build packs. But these are these are just Docker images, so they can do anything. They can install RPMs, or they can go and download things from the internet. It's a much more powerful build environment. And so that ability to manage the life cycle of an application is really what OpenShift is all about. And along the way, we added a lot of other features, some of which have made it into Kubernetes as well now. Things like access control and security. OpenShift is a multi-tenant container platform. So obviously we need to do things like preventing everybody on the cluster from getting root inside of a container, or preventing people from taking too many resources. So things like quota and access control are features that the OpenShift team actually contributed back to Kubernetes. And most of the things that we think of as OpenShift today, we think of as the enterprise aspect, being able to run a multi-tenant container cluster, not just one for myself, but then also being able to manage and run applications. And there's a lot of exciting stuff coming in OpenShift over the next couple of years to say, well, what are the other tools that you need? How do I continuously deploy and continually integrate software on top of a cloud platform and really take advantage of that? Not just being able to run my production applications, but what if I want to spin up a test application, run my end-to-end tests against it, and then spin it down kind of in a hermetically sealed bubble? And a lot of those things are things that will continue to evolve in the larger Kubernetes ecosystem. But in OpenShift, that's really our bread and butter, is making it easy to build and develop applications.
Kubernetes has these abstractions that we've already talked about: a pod, replication controller, service. There are other abstractions. OpenShift has its own set of abstractions, and I want to talk about these. In OpenShift, containers are called gears. A gear is a container that is allocated CPU and memory and disk and network bandwidth. Why didn't you just use the term container? Explain the difference in abstraction between gear and container.
Well, and actually, that's kind of the old terminology. So when OpenShift started, most people had no idea what containers were. And so gear was really a way of, when you think about how you bring together a bunch of independent units of computation, you had the VM concept. But in 2011, nobody knew what containers were. It really took the rise of Docker to bring that up. So a gear is really what we used to just call an old container, or what containers would be called today. We've actually removed that terminology. When we think of OpenShift today, OpenShift is just Kubernetes plus the features on top. And so all of the core Kubernetes concepts are exposed and available in OpenShift. So again, we don't actually even use the gear terminology anymore. We just say containers and pods and replication controllers and services.
I see. So does the same go for the idea of container images? Because I think, if I was reading about this correctly, a container, like a container image is called a cartridge. So has that vocabulary also been deprecated, or is there still the idea of a cartridge?
No, definitely the idea that is the old terminology. So today, OpenShift is completely image focused. But I think a lot of those ideas around cartridges are actually things that people are finding. So the idea of a cartridge is you want to be able to offer a chunk of software, like a
plug and play.
Yeah, plug and play framework. And it's not just enough to have a package. You can't just you can't do apt-get and have a Ruby framework running that includes your code. You got to have those little bits of glue code around it that says, okay, well, I'm going to take your Ruby code and I'm going to do a bundle install. And so just like Heroku build packs, like a Heroku build pack is a set of Ruby code that runs on top of an Ubuntu base. The cartridge was a bunch of script and Ruby and Python code that ran on top of a Fedora and CentOS and Red Hat Enterprise Linux base. Each of those little connection points, those little affordances that are there to help developers, like, hey, I'm going to go install your gems for you. You don't need to worry about it. That's really the fundamentals of a cartridge. And if you look at what people are doing in images today, all of those same patterns apply. So for instance, if you look at the MySQL image that is published on the Docker Hub, that MySQL image takes environment variables that go set up passwords for you, and they do the pre-configuration of the MySQL image. But every bit of that tuning that when the container starts up, it needs to figure out how much memory it has and scale itself appropriately, or if it wants to take source code and build that up. Each of those concepts still exist today. We just don't have a nice formal name for it anymore in the container world. We say, well, it's an image, but some images are better than others.
So in OpenShift, you have an application, and the application is defined by a config. Explain that process of making an application, and what does an application consist of, and maybe you could articulate how it's defined via an explanation of the config.
Sure. So in Kubernetes, we have pods and replication controllers, and you have services. On top of that, you want to be able to say, hey, every time I have a new image available. I want to go roll that out. So in OpenShift, we call that a deployment config. And a deployment config looks a lot like a replication controller, but when you change it, it goes and orchestrates a rollout for you. And so that idea is actually, astute listeners, people who've been using Kubernetes will be familiar with that. That's what the deployment object in Kubernetes is based around, that idea that there's a simple declarative definition of your pod that you change, and that manages the rollout for you. So that's the one bit. So again, it's OpenShift added a concept, and then we've added that into Kubernetes, and we'll continue evolving it. That is a definition of your containers, your pod, your environment variables, how much resources you want, really all the same things that are in a pod. But on top of that, OpenShift also uses the same config objects as Kubernetes. There's nothing that's fundamentally different. So we have services, just like Kubernetes, and the service is a definition of what you want to serve. And then on top of that, OpenShift has added routes. And so a route is the ability to say, I want to be exposed to the external world. In a way, you don't always want to expose everything that you run inside your cluster to the outside world. It might not have a password on it. It might be a debugging port. And so the route's really how you communicate that. So in an OpenShift application definition, you'd have a deployment config, you'd have a service, you might have a route. Routes would be familiar to Kubernetes readers as ingresses. We took the core route idea and worked to get it into the upstream community on that. And then the most fundamental part is obviously a build. So you want to be able to take source code and combine it with another image or a base runtime, and then have an image that gets repeatedly deployed. And so for OpenShift, that kind of the fourth bit is a build definition, which takes source code, a Git repository, or you can push binary contents directly to it, or you can pull down other images and suck contents out of them to build a new image. And when you push that image, that actually triggers a deployment. So again, a lot of the concepts in OpenShift are very familiar to most Kubernetes users. They're layers on top. This is kind of what I talked about at the beginning. Kubernetes is designed as this composable system. We want to have core ideas that you can build these layers on top of. An OpenShift application is really a Kubernetes application with some of the additional tools that a developer might want to be able to push code. And to make that a little bit easier, OpenShift has a number of command line tools and web tools that allow you to easily pull together all of these bits. Sometimes people say, well, Kubernetes has so many concepts in its API objects that it's really hard to approach them. And so in OpenShift, we actually have a number of tools that you give us a Git repo, and we can spit out the full Kubernetes application and run that for you, do the builds for you automatically, so that you get that PaaS style experience, but you still have that top to bottom control.
Is it at the level where when you spin up a new OpenShift project for the first time, it's as simple and seamless as if I'm setting up my first Ruby on Rails application? Like, is it that level of speed to, from zero to hello world?
This is an interesting one. There's all sorts of different types of developers out there in the world. And to anybody who's been working with Docker for a couple of years, the idea of spinning up a container and running a whole containerized cluster, just on your laptop is starting to feel a little bit like old hat. There's a lot of things in Kubernetes and OpenShift that make it easy to just get running in a single container. But for a lot of other developers, once you have an OpenShift installation, which can it involves some knowledge about Docker and what's going on in the system. But yeah, once you have that cluster running, there's a easy use command line that you say, I want to build a new application from this Git repo. And we'll look at the Git repo, figure out what it is. So if it's a Ruby repo, we'll see the gem file and we'll say, we want to pair this up with a Ruby image that an administrator or comes pre-canned with the system, and off you go.
So if I work at a company where I'm building the entire software infrastructure on OpenShift, I might want to use a template to standardize how I create configuration for applications so that anytime a new developer wants to build an application on the platform, they can use that template. So explain why a template might be useful to standardize how things work across an organization.
Sure. So if And I think this is something that we thought of early on, is that if we want to have all this power, the ability to be very expressive, we needed to have a simple concept to kind of tie that all together. And so a template in OpenShift is a simple parameterized set of Kubernetes and OpenShift API objects. So if I wanted to take a Ruby application that I had running, I would just grab those API objects, put them in a template file in their native form, JSON or YAML. And I could go in around those objects, I could add parameterization. So for instance, if I wanted to parameterize an environment variable, like the password of my MySQL database, that's something I could very easily do in that template. I would say, I want to replace the MySQL password environment variable in each of these definitions inside the API object. So it's really a simple packaging of API objects. And that simplicity was really key. We didn't want to create an abstraction on top of Kubernetes that hid all the flexibility, but we wanted to make it more approachable. So a template is really a formalization, a parameterization of something that works. And when you deploy that template, you're really just going and creating each of those objects with that simple substitution. And so for a lot of the, when we think about this in the, software is hard, right? There's a lot of things in building web applications that requires you to get in the guts of the code. And we wanted to make it easy to have pre-canned examples that showed people where to start. So if you're coming into Kubernetes for the first time and you've never had to go deal with a pod or a service or replication controller, the idea of a template is the template can show you it working and then help you walk backwards and find those steps so you can dig into the details if you want to add all of the power of Kubernetes, things that help your application keep running in production, like health checks and liveness checks, setting resources, security controls, and the like. And so if I'm a large organization, I might build templates for my developers that are the pre-canned base application definitions I want them to use. So a Tomcat stack or a Java OpenJDK stack that's got all of my standard jars in it. And the developers are still free to go and customize that and bring their own code, but it's a starting point and helps them get up to speed quickly.
Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SE daily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE daily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SE daily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. When I think about usability things that we get out of OpenShift, by what we get out of this layer on top of Kubernetes, one thing I think about is continuous integration. Does the continuous integration experience, like the Jenkins integration, does the OpenShift integration, does that give you a lot of value add on top of whatever continuous integration workflow you would have on just naked Kubernetes?
It does, and this is a really active area of development for us right now, where in OpenShift, we wanted to make it easy for you to define a process that keeps working. So I talked about build configs and deployment configs. So I set up a build, and I can set up a webhook or a pull. And every time my source code changes, it starts a build. If the build succeeds, that pushes an image. If the image gets pushed, it updates the deployment, and the source code rolls out. So that's that idea that as a developer, what we really want to get to is defining the process where we're continually changing, right? That's the heart of Agile. That's the heart of DevOps is using the automation and all these tools to help us get what we actually have to get done, which is, deploy software, build and deploy software. And so we have these base concepts in OpenShift that let you do the simple flows. But in reality, and I think this is a recognition of the difference between Kubernetes and all of the paths that came before was the world isn't so simple that you can just get away with saying, well, we're just going to run 12-factor apps. And just like that for continuous integration and continuous deployment, the world isn't so simple that you can say, well, we're just going to push a single image and then run some automated tests and roll it out to production. And so with that observation came the fact that, well, we want to have the best possible platform for running continuous integration and deployment. And to us, I pretty strongly believe that that's Jenkins, because if you look out there, the Jenkins community is one of the most thriving, vibrant CI/CD communities that has ever existed. There's plugins for practically everything you could imagine. And what's more, the Jenkins community has really reacted to the evolution of CI/CD by taking a lot of those lessons to heart. Jenkins 1.0 has been out for quite a long time, taking those ideas to heart and using that to build the next version of Jenkins. So Jenkins 2.0 puts at its heart the idea of a pipeline. And that pipeline is a definable process that you can use all those Jenkins plugins if you want, but you have some central definition that says, here's how my code runs through the lifecycle. And to us on OpenShift, well, we have a platform that makes it really easy to spin up and run applications, to consume cloud resources, to do builds on demand on the cluster infrastructure. And to us, so that marriage of Jenkins pipelines with OpenShift is really fundamental. So with OpenShift 1.3, which will be coming out later this year, and actually the very first alpha release of OpenShift 1.3 was just released yesterday. So we've started to publish some of the first pieces of this. You can, on OpenShift, you can push a Git repo that has a Jenkins file in it. That Jenkins file, which is really the heart of Jenkins 2.0's pipelines, will actually cause the platform to spin up Jenkins to run that build for you. And then the Jenkins plugin, we've built a number of plugins in the open community that let you leverage OpenShift as a place to run, build, and deploy applications. So you kind of get the best of both worlds. You have all the flexibility of Jenkins, but OpenShift out of the box is giving developers a way to not have to think about the details of managing a Jenkins server. Instead, we think that Jenkins servers really should be a tool that, just like Kubernetes can summon whole compute infrastructures and storage resources and networks to your beck and call, we want to make the same thing easily available for bringing builds and applications. So in your Jenkins file, being able to do very complex deployment and testing that you don't have to think really about where things run or how much resources they're all just running containers on OpenShift.
Well, it's so relevant because there's all kinds of different testing workloads, just like there's different database workloads, and it makes a lot of sense. So, average listener right now probably is working at a company where they have Ruby on Rails deployed to AWS, or they have like a Java Spring application running on their own servers, or maybe on Azure or something. So there are all these different states that companies are in. How do these different companies, what are some typical migration strategies for migrating from X to OpenShift or even just to Kubernetes? Like what is this typical migration look like when you're trying to get onto OpenShift?
That's a great question. I have to say that this is probably the thing that I spend a lot of my time talking to people about is
the switching cost.
That's right, is that everybody has an investment, and that investment's really important. So if I've built a CI/CD pipeline with Jenkins and AWS and I'm using that, it always comes down to what value do I get out of switching? And one of the primary goals that we've tried to keep in mind as we've developed OpenShift is that nothing that we've wanted to do should feel like you have to completely upend your entire process in order to benefit from something like Kubernetes or containerization or on-demand Jenkins. And so at every level, we've kind of approached it from the perspective of people are generally looking for opportunities to improve their workflow. And they do that if it's easier, faster, and simpler, and they can understand it and control it. And so a great example would be if I've got an application that I'm looking to move into Docker containers, at the same time, I might say, well, I'm doing this so that I can bundle up all my dependencies and set up a reproducible workflow and be able to test the same thing in development that I do in production. But then the next question that usually comes up is, okay, well, how do I set that pipeline up? And there's a lot of options. You can run Jenkins, you can build bash scripts. A lot of people out there you can use the Docker Hub. A lot of people are using variations on this tool. With OpenShift, we wanted to make it as easy as possible to say, well, we can provide the builds to build images, but you don't have to deploy on OpenShift. You could just use OpenShift as a very simple build orchestration engine. We also look at it from the other perspective, which is a lot of people come to Kubernetes and say, well, I want to run my production applications on Kubernetes, but I'm not yet at the point where I find value in developing on top of Kubernetes. And so we tried to approach it from the perspective of, okay, well, if Kubernetes is really great for big, large deployments, can we make it easier to run a local deployment of OpenShift where you can test out that same deployment that you'll use in production? Because again, you can test everything in Docker containers on your machine, but the primary value, the thing that we say we really want to be able to do is enable people to move from dev to production without changing anything. If I've got to go rewrite all of the glue code or the compose files because my operations team doesn't let me run as root, or I'm running a different network, or I've got different load balancing rules in production than I do in development, one option is to say, well, I'll just do it two places. But with OpenShift, we've tried to make it so easy to run OpenShift locally in a container that you could test everything on your local box. If you're working with Docker containers, you can build these images, test them all out, push them to OpenShift, see how it is, and then push to production. We've tried to meet people where they are. And I think this is the hardest problem in computing, which is how do I pick the next new thing that's going to make it easier for me to do my job? And there's no one answer that unfortunately solves everybody's problems. It's be useful in all the different ways that people need you to be useful.
Well, one tactical analogy I think about is that when Netflix was migrating its infrastructure to the cloud, the first thing that they migrated was the job board. And so they took this strategy of the minimum impact to how the company works in order to test out this new key piece of infrastructure, because it created this extremely low pressure environment. So once they got the job board on AWS, they're like, well, this works just fine. Okay, let's move the movie ranking system or Netflix for kids or some other small component. And then as that process gets standardized, as you learn how to move something to the cloud or move something to OpenShift, then it becomes baked into the culture just naturally, gradually. So I don't know. Does this sound like a plausible route to onboarding? Like you basically fork the infrastructure and you start migrating small things to it?
Not only is that plausible, I think that's probably the only thing that actually ever works, which is to be confident that something's going to work. You have to try it, and if you haven't tried it, it's probably going to fail, or at least you stand a lot lower chance of success if you make a big step before you make a little step. We've actually seen this a lot. So typically when people adopt OpenShift, they come to OpenShift, they want Kubernetes, but they also want the controls around who can do what, quotas, security, RBAC, integration with LDAP, all those things that we add on top of Kubernetes. And what they typically do is they start with one class of application. And it's interesting, OpenShift kind of in the generation one platform as a service world, it said, well, make it easy for developers to experiment and then push to production. But in practice, what we see a lot of is what you said, is people taking an application, and they might have processes fully defined for how they build that application, but they don't have to change those. At the very end, they would say, okay, well, we're going to run the last step that converts this to the config files that run on OpenShift, and we can deploy that to an OpenShift cluster, and they'll run one or two applications and get comfortable with it in transition. What we've also started to see actually is people bringing workloads to Kubernetes that actually don't even look anything like what we typically think of as a platform as a service workload. So people who are bringing job frameworks, or people who want to run very large, trading applications or complex applications, but what they're really looking for is a standard application environment And it's been a challenge, which is we've kept going through these successive generations. You can go with AWS, but then you have to make sure that you don't get too locked into AWS if you want to jump to Azure, or you build something locally on OpenStack, but it doesn't work when you run it on someone else's OpenStack, or you don't care about OpenStack at all because you're just a small dev, but you want to see some of this value, so you want to run on Docker Swarm. And at the end of the day, what we've tried to do with OpenShift is we want to make and we think this is really what Kubernetes has really succeeded at, is it has all the right patterns in place to be a great place to run applications. And our goal will be to help people be able to run those applications anywhere. And that should mean anywhere from a laptop to the cloud to a data center to a couple of machines that are sitting over in the corner, that you want to try this out and get used to it. And I think that kind of adaptation, the reality that you're looking for something that makes it easier for you to stay flexible, is a big part of what people find value in. They want to be able to move workloads from place to place, and Kubernetes and OpenShift, I think, are a great place to do that.
So I was at OSCON recently, and I spent a lot of time walking around the vendor booths because I like talking to the vendors and getting a sense of the market and how people are thinking about things, how they're marketing their products. And there is so much confusion in this space. There is so many of these cloud and platform as a service and container things, whether we're talking about OpenShift or Cloud Foundry or OpenStack or Docker or Mesosphere or EMC's offering or whatever thing Rackspace is trying to get me to buy. And I have no idea how to make sense of this. And I spend basically all of my time as a journalist in this environment. So, for developers who are in it, I imagine it's even harder because, you not only are you trying to assess these different things, you're trying to get your work done day to day. And all of these different companies are trying to sell you this vision that, oh no, don't listen to those other guys. We're the ones who have the real cloud. So how as a developer in this world, how the heck do you make sense of all these different products?
I think that it is only going to get worse from here, which is kind of a scary thought. But it's also
it's literally like going to the store and you see like organic and natural and like homegrown, and you're like, what the hell are these things?
But at the same time, it's fantastic, right? So if you think about 20 years ago, you could maybe cobble together some bash scripts that with SSH and some keys, you might have a chance of running something on a couple of different machines, maybe, if you didn't look at it too hard. But if you then you look around today and you say, well, I don't just have one choice for these massive cloud scanning applications. I don't just have the choice of one environment. I have tens or hundreds. And in some respects, it's a great thing because it forces everybody to think about what actually matters, which is how can you actually improve someone like a developer's life? And at the end of the day, the beauty of all this choice is that it's pretty easy to filter out the things that aren't useful to you. And everything's kind of useful, right? Like at the end of the day, all the vendors love to posture and say, my platform's better. I can do this. I'm faster. I can handle greater scale. But at the end of the day, we as developers get to say, well, you're all pretty good. I'll just use one of you. And the hard choices usually come, well, is this secure, or can I change this easily? And I think if there's one saving grace, is that open source as a community, all the different types of open source, not just the grizzled, graybeard sitting in his basement, slamming out Linux kernel code, but the guys in Silicon Valley, the people all over the world in China and India and Europe who are actually contributing to this massive experiment of open source, and it's all available to us. I think that is really, I think we win even with all these choices, is that we as developers have more power than we ever have, and it's only going to get better. So I can sometimes be cynical about all the choice, but at the same time, I think, well, if what we're offering, if what we're building to enable developers isn't good enough, then it'll get replaced by something that's even better. And that's really the exciting part of being, involved in Kubernetes and OpenShift and Docker as a whole, is that it is this ferment of innovation that has driven everyone to build better things. And the hard part is really picking. I mean, if the worst problem we have is this surfeit of choice, I think I can live with that.
In the name of not succumbing to the obfuscation and the confusion, I want to, I guess, dive into a few of these other products, these other tools. So OpenStack, I did a show on OpenStack recently, and OpenStack is a platform as a service, and a platform as a service usually runs on top of an infrastructure as a service. Or, I'm sorry. No, I said that wrong. OpenShift is the platform as a service. OpenStack is the open source infrastructure as a service that companies can use underneath OpenShift. So talk more about the relationship between OpenStack and OpenShift and like how that's going to evolve over time.
Sure. So it's been really interesting. OpenStack has started to reach kind of what we would maybe call maturity, right? People are fairly comfortable with it. They know what they're getting. They're not on that crazy upgrade cycle necessarily. And so OpenStack really helps people more easily deploy virtualization. I think at its core, OpenStack has done a great job of bringing all the tools that help people make that transformation. The big cloud providers kind of incentivized everybody else who didn't want to run on the cloud to build something that offered that equivalent feature set, the ability to run VMs, the ability to deal with storage and block devices somewhat generically, and all the myriad of projects to manage networks and, Swift and the ability to do something like S3 and object storage in a standard way. All of those tools are really fundamental to building applications, but they're not enough. And I think that's where, one of the things we talk about when we think about what is the distinction between Kubernetes and OpenShift and all these other things out there in the world is, to me, the goal of Kubernetes is to be the best place to run applications. And by applications, I mean the things that we build day to day, web applications, networked applications. And up till now, a lot of the times we've been thinking about this from an infrastructure perspective. How do I get more VMs? How do I get more storage? And Kubernetes and OpenShift is an opportunity to turn that discussion around and say, well, what do we actually want as applications? And then we don't have to worry about all those details of the infrastructure. That's somebody else's problem. So, everyone is happy to go do it themselves when you're using the cloud or running on top of OpenStack because it's better than what we had before. But I think our, kind of the position I see is it's not enough. We want to blur those lines. As an application developer, I want to specify what my application looks like and what it needs. And that's somebody else's job to make sure I get the storage I want. So the conversation really becomes, instead of saying, I want this VM and I want to install this patch level and it needs to be connected to these networks, we change the discussion to say, I need a network address. I want it to be fairly high performance. I need 10 gigs of storage, and I don't want you to restart me more than once a month because I'm a production critical service. And so it moves the discussion to more about what the application needs rather than the how, the why. I need this application to be running 99% of the time versus, well, I hope nobody restarts that VM accidentally. So I think the future is tighter integration between infrastructure, right? The APIs, the patterns, the tools get easier to use. And that enables us to build better abstractions that say, I don't really care what kind of storage my application uses, as long as it's fast, no one else can write to it at the same time. And when I need it, it gets snapshotted and backed up, and I don't have to think about it. So it's really about going that extra step above infrastructure to think about application first.
In your vision of the future, should everybody be using Kubernetes and potentially OpenShift, or is there a place for these other schedulers like Docker Swarm and Mesos and ECS?
I think there'll always be lots of reasons that people want to make investments in lots of different spaces. I think our job with OpenShift, the thing that gets me up and gets me to work every morning is I want to make it as easy and as powerful and as useful as possible. And so I think there'll always be reasons that, ECS is a great example. ECS has close integration with a lot of the AWS APIs. It makes it easy to go do these. You can point to features all day long and say this has it or this doesn't. But kind of getting back to that earlier point is I think our goal is to be as good as we can in OpenShift and Kubernetes at running applications. And if we succeed, and that's useful for end developers, then people will want to run on it. And I think there will be a place for the different kinds of workloads. Kubernetes, we want to build a really great platform for running all kinds of applications. But I think the catch in that, the asterisk, is it's a lot of work to deal with all of the complexity of the world. And so I think you'll always have some level of, there's things that Docker Swarm can optimize for, like being able to start containers as absolutely fast as possible, that we don't worry about in Kubernetes, because our job is trying to move to that higher level abstraction, saying, I don't really actually want to deal with individual containers. I want to deal with a service. And so some of these levels of abstraction come with costs.
And Mesos potentially is even higher level, kind of the opposite view. The distributed system for distributed systems, whatever that means, would actually, I could totally, I don't mean to sound like I'm incredulous or anything. I think that's actually a plausible future where, just like you said, Docker Swarm, maybe you can have closer control over the containers. Mesos, maybe, there's this future where I want to be able to manage all of my different Kubernetes instances from the point of view of Mesos. And I don't know, but like I think it's one of these things where, like, right now you have to squint in order to see the differences, but over time it will become much more delineated.
And I think that's a great example. There's a lot of great work that's been done in Mesos, and we know of a lot of people who build and run job frameworks. One of the distinctions that I draw between Mesos and Kubernetes is Kubernetes is very focused on making it easy for you to run highly scalable, resilient, redundant applications. And I think if you look at when you're running a Mesos framework, Mesos at the lower level doesn't provide that. Something like Marathon or Kronos does. And so if you think about what Kubernetes is, it's really an equivalent of, it's a single system that tries to do Mesos plus Marathon plus Kronos, and to do it with a consistent set of objects that are all well aligned with each other. And so there'll always be areas where getting down to the metal and something like Mesos will actually give you an advantage. You can run faster, you can schedule more because you're focused on a different problem set. And it is an interesting challenge. I do think the one thing that always gets back to me is that Kubernetes was designed, by the same, Kubernetes, the people involved in the Kubernetes community from the Google side are the same people who helped design Google's internal cloud infrastructure. And so there's always these we have a lot of great discussions where you can see how the perspective of running these things at Google, where the kind of the classic phrase they say is the data center is a computer, that mindset really permeates. So there is no alternate scheduler in the Google worldview, because you have bare metal running the Borg, the internal equivalent of what Kubernetes is an evolution of. They run that and they run their workloads on top of it, and they can build everything they need to support that. And so there really is no other layer. But then you get out in the messy world of open source, where you have all these systems that fit at these different layers, infrastructure as a service, things like Ansible and Puppet and Chef that do lower level config management. You have people who have existing workflows. And I think that's what you see, is that everybody has particular things that have, nobody's coming at this from a clean slate. They all have accumulated processes and workflows. And it's sometimes tough. Like, the Kubernetes mindset is very much, metal to the sky. But in the real world, people adapt these new tools like Kubernetes to fit into systems that they already have. So I think it'll be interesting over the next couple of years as the space grows between the different container orchestrators.
Right. Yeah, we are not Google, and so therefore we have to deal with things like integration and more real world issues. I think it's so interesting, because for many years we've had this dynamic with Google where Google releases a paper as soon as they have something that is like 10 years ahead of the paper. And so what I wonder is, like, what does Borg actually do? Like, is Borg 10 years ahead of Kubernetes? Are they doing something, some other kind of abstraction or tool set that is more powerful than Kubernetes? Or have they shifted that internal mindset to say, okay, we want to dominate the cloud, and in order to dominate the cloud, we want to move to the Amazon mindset, where our internal infrastructure, we would love to externalize as much of that as possible?
This is a really interesting question, and I won't presume to speak for any of my fellow Google Kubernetes contributors. Some of whom, having worked with for 2 years, the friendships and the bond and the community has been really strong. I won't presume to speak for what they're doing internally, but I think one thing that I've noticed is that everybody on Kubernetes has a sense of pride and applying lessons learned. So I can't say for sure whether Google has something that's 10 times better internally, but I can absolutely say for sure that the focus on Kubernetes is to learn from all of the decisions and choices that Google made internally, but also to learn from the open source community. I remember an early discussion we had on a Kubernetes issue where we were talking about health checks, and if you have a health check in Kubernetes, it'll restart your pod or restart your container if it dies, but it also can be used to add you into a load balancer. And there was a particular discussion which was, well, I don't think this is really an issue because the health check would catch it. And I was like, well, but you guys know that 99% of software that comes out of the box out there doesn't have a health check. And there's this really long pause where you saw that whole worldview shifting. And I think that's a little bit of the dynamic that we've had in the Kubernetes community. It's taking these lessons learned from 10 years of Borg and saying, we don't want to make those mistakes again, but then also taking the lessons from the open source community, from all the contributors, from Red Hat, from CoreOS, from people from Meteor, from the individual people who just drop in to say, I'm running this workload and I need it to work better, is trying to gather those patterns that actually not just on the open source side, not just on the Google side, but kind of everybody's problems and put them together. And that has been, I think that's been the source of all of my funny stories, as well as all of some of the most enjoyable discussions where you get to see someone else's perspective about how they run things, and you tweak it a little bit and you see these patterns emerge. I think I would kind of characterize it as, we had the Gang of Four for design patterns for computer science. And then we had patterns of enterprise application architecture for Java EE applications in the 2000s. I think Kubernetes is patterns of distributed application development. And it's been a real treat to work on the project and to see all these patterns come out.
All right, well, let's close on that note. Clayton, thanks for coming on the show. It's been a really interesting conversation. I'm a big fan of OpenShift and Kubernetes. Everybody can go check out OpenShift, Red Hat OpenShift. Yeah, appreciate it. Great to have you on.
Thank you very much. I appreciated it.